Okay, let's figure out how to solve cubic polynomials. So here's two. X cubed minus 7x minus 6 equals 0. This is a cubic polynomial as well. If you expand this out, you get like x cubed and some other stuff. This one is really hard to solve. This one is really easy to solve. So let's do that first. Here we go. Okay. One solution to this cubic polynomial is x equals minus 1. Why? Well, if x equals minus 1, you have here minus 1 plus 1, which is 0. 0 times whatever other stuff gives you the answer 0 that you wanted. So to solve this equation equals 0, it's really easy to look and see, okay, x could equal negative 2, and I'd get the answer 0. Or from this, x could equal 3, and I'd get the answer 0. And that's something that you're very used to doing from Nat 5. And all we're doing is looking at these factors and basically flipping the sign to get the solutions, also known as roots of this equation. Okay, let's try and do this one. The only way to do this one is basically to start by lucky guessing and to do exactly what we just talked about. So here, look, if x equals 3 here, I put in 3 there. I've got 3 take away 3, which is 0. 0 times some stuff, and I'll get the answer I wanted, 0. So I'm going to do some lucky guessing. Let's start an easy one. If I lucky guess that x is in fact 0, what do I get coming out of here? I'll have 0 cubed. I'm just going to put 0 in everywhere x is. Take away 7 times 0. Take away 6. And what does that equal? Well, that equals negative 6. 0, 0, negative 6. That is what we call the remainder. Okay, this is the remainder when I divide this polynomial by x minus 0, and it's not the answer I was looking for. I was looking for the answer nothing, and I got an answer that's not 0. So that didn't work. Let's try again. More lucky guesses, please. Let's do really easy numbers first. Okay, so in exams, it's always going to be basically 1 minus 1 or 2, or like a really easy number like that. X equals 1. I'm going to have 1 cubed from here. Take away 7 lots of 1. Take away 6, which I think is going to give me, that's 1, that's minus 7, that's minus 6. It's like negative 12. So this is my remainder. This is my remainder, negative 12. It's not the answer I was looking for equals 0. That's not helping me. Okay, let's try x equals negative 1. I'm going to have negative 1 cubed minus 7 times negative 1 minus 6. So that bit, minus times minus is a plus, times another minus, and I've got minus against that. That's negative 1. Minus times minus there is positive 7, negative 6, and that does in fact equal 0. Look at it. So this means what? It means, therefore, I have a solution. I've found a solution. I've started to solve my equation. The solution x equals negative 1 is part of my story here. Another way of saying it, I've got a root at x equals negative 1. Another way of saying it, therefore, these 3 dots meaning therefore. Therefore, x plus 1 is a factor. What did I just do? I just did the opposite of this. What I've found out is that because x equals minus 1 is a solution, it gives me 0. That means x plus 1 must be a factor. It must be somehow involved in the answer. Why? Well, if I'm putting in minus 1 and I get the answer 0, the only way you can turn negative 1 into 0 is by getting your negative 1 for your x and adding 1 to it. You can't times it by anything to get 0. The only way to turn your negative 1 into a 0 is to add 1 to it. So this component has to be involved somehow in this equation here in order for me to get the answer 0 when I put in x equals negative 1. Okay, so this is called the factor theorem, and we've found that this is a factor by finding out that this is a solution by doing lucky guesses of the easy numbers. It'll always be x equals 1, minus 1, or 2, or 0, or something in the exam. It'll always be one of these. Right. How do I go further? How do I solve this completely for all three solutions? Well, what I'm going to do is put together the knowledge that I have so far. Right. I know that I started with x cubed minus 7x minus 6 equals 0 as my challenge. I know that one solution is x equals negative 1. That solves my challenge, and I know I'm probably looking for two more because cubic equations tend to have three solutions, the numbers here. Okay, so I know that this equation can be written as x plus 1 times by some other stuff, because this must be a factor, and that's the whole point. When I put in minus 1, I get 0. That means x plus 1 is a factor. So what goes here? Well, to get x cubed, I have to have x times what? That's got to be an x squared. To get the negative 6, I have to have 1 times what? That must be negative 6. And now I just have to figure out what number, if anything, goes here, something x. Well, let's see. So the 1 times the x squared gives me 1x squared. But in my kind of answer here, I don't have any x squareds. So I'm going to have to here have negative x. And why is that? Because the 1 times the x squared gives me 1x squared. I therefore need this, so that x times negative x gives me negative x squared to get rid of it. Here's another way of looking at it. Okay, I need to get minus 7x. This x times the minus 6 gives me minus 6x. I need another minus 1x here, so that when I times it by this, I get my minus 7x's, my negative 7x's. So this factorising is actually quite a lot easier than the normal factorising you're used to of quadratics, which is what we will do now. I will finish off by factorising this quadratic into two brackets in whatever way you normally use. I normally use the same inspection kind of way. So there's x squared, that's got to come from x times x. I've got negative 6, so I'm thinking maybe 2 times 3. And I'm thinking negative 3 and positive 2, so that when I expand it out, I end up with just negative 1x in the middle there. So what we found is that actually this equation here was precisely the same as this equation here. This one was really easy to solve straight away by just flipping the sign to get all the solutions. This one, to solve it, I first have to lucky guess a few x values till I find one that gives me the solution I want. Here, equals 0. Then I know what that factor is, and I can work my way through. You have to find out this quadratic one if you want to get the marks in the exam, and then you can factorise that on just how you normally do. So there we go.